Hi, I'm Nick.
I'm Luke, and today we'll be discussing Gay-Lussac's law.
The Gay-Lussac law was developed by French professor Joseph Louis Gay-Lussac in 1802.
The Gay-Lussac law states that when kept at a constant volume, the pressure of a gas will increase when its temperature increases. Thus, the temperature and pressure of a gas are directly proportional to each other.
When a gas increases in temperature, its particles begin to move faster and begin to bump into the sides of the container they are in. The equation for this law is P1 divided by T1 equals P2 divided by T2.
Alright, so let's say that a certain gas has a volume of 10 liters and exerts a pressure of 97 kilopascals at 25 degrees Celsius. What would the temperature in Celsius be needed to change it to standard pressure?
First, we need to change the temperature from Celsius to Kelvin by adding 273 to 25. We also need to remember that standard pressure is at 101.325 kilopascals.
Alright, so when we divide 97 by the 298 Kelvin, we get about 0.3255. We then multiply both sides by the unknown temperature x, and then we divide both sides by 0.3255, and we then find that x is about 311.287 Kelvin.
Since we need the temperature in Celsius, we subtract 273 and get 38.287 degrees Celsius.
A real life example of Gay-Lussac's law can be seen in gun shells. A cartridge is made of three main components: the primer, which is mercury, which is Hg, gunpowder, and the projectile.
When the firing pin of the gun strikes the primer, it ignites. The primer then ignites the gunpowder in the cartridge.
The gunpowder then ignites, then releases a gas that increases in temperature almost instantaneously. The heated gas particles inside the shell, which stays at a constant volume, cause the pressure to increase.
The pressure inside of the shell becomes much greater than the pressure outside of the shell. The bullet is then propelled from the shell and out of the barrel of the gun.
Now, we're going to have a separate video to show you guys a little demo, so yeah.